Hi, Steve from Steve's Makerspace. Today we're joined by generative artist Jeff Palmer, and we're going to be going over how to create circular flow in a flow field. I used this method to create this art. In my last video, I talked about how to make a flow field. I wanted to add circular flow to the flow fields. My first attempt to create circular flow was to create a center of rotation, which I talked about in this video a good while ago. Unfortunately, using that method left a gap at the top. I don't know why. My second attempt to create circular flow was to use a buffer canvas, draw a circle using arcs with each arc having increased color values. Then on my main canvas, I grabbed that color and converted it into a flow angle. That resulted in good flow for the first quarter of the circle, but as it continued around, the flow became chaotic. I was stuck at this point and posted about it on Twitter. Jeff Palmer replied that he had a solution for me, and he was kind enough to do a Zoom call with me to discuss it. We talked for about an hour and 15 minutes, with him talking me through the code. I'm going to be summarizing this for you with some snippets of Jeff's comments. Here I'm showing some of Jeff's work. I'll leave a link to his website and fxhash profile in the video description.
What I do is, like if you have a 2D noise field, I need to figure out how to turn those values into vectors that I then use as direction. And then I don't do things like draw arcs. I will trace points through the field and then just connect them with lines or draw dots or something like that. So I have built a creative coding library that for myself that is like extremely deficient in primitives. It like has circles and rectangles, and that's basically, and lines, and that's it. So everything I do is sort of like I drag points across a canvas or whatever to make shapes.
So you want to start from scratch?
Yeah, maybe.
If you have the time. It might take a while.
This is my job. I just hang out and make art. So I've got time to do this.
Awesome. Let's go.
Are you familiar with SDFs, like defined distance functions? A lot of computer graphics folks use them. They're because you can easily sort of compose them into different shapes. And so it, like, for example, defines the distance from like a circle on a plane. And it's a way to sort of easily put a shape into this 2D space that you can combine and smooth and do all these other things.
According to this article by Ankit, a sign distance function or sign distance field gives us a distance of point x from the boundary of a surface. The major advantage of this function is to determine if a point lies inside the boundary of the surface or outside the boundary.
A very similar thing is to just compute maybe distance from the center.
Here's the start of the SDF that he showed me. First, we converted to color mode HSB, create a nested loop to go through the points of the width and the height, but with a gap. Then we use the distance formula to get the distance from any point in here to the center of the canvas. Then we convert that distance to a color using a map. So if we're looking at the I and j of this point right here, the distance would be 0, which would convert into 0 for the HSB color wheel, which would be red. If I wanted to move this circle, I could say width divided by 3 and height divided by 3, and now I've got the circle at the thirds position.
When I said in my tweet that you want to create the gradient, so are you familiar with the gradient?
I mean, isn't this a gradient going from here to here?
Color gradient, yeah. There's a mathematical gradient, which is like the slope of the surface. If you were to make this height, this distance into height, right? So it would be kind of like a cone around that point.
Sure.
Right. So and then if gradient is sort of like a vector on that plane that points in the direction of decrease or increase. They use it in a lot of, it's like for finding maximum functions, and they use it in machine learning, and it's sort of a super helpful tool for exactly the kind of thing that sounds like you're trying to do. So what we want to do is figure out the gradient for this function.
So next, Jeff showed me how to take that color gradient, turn it into a gradient that creates vectors and does something like this. We'll go over that code now. We still have the for loop, but we've gotten rid of the colored rectangles, and we're calling this make gradient function. So we'll go to the make gradient function, and in the make gradient function, we're going to call a distance function, which is right here, And the distance function is going to get the distance between whatever the I and the j is, and in this case, the center of the circle. And it's going to return that distance to this function, and that we're going to call center1. Then we're going to get the distance function again, but this time for a point to the right of the I and the j. And then we're going to do the same thing and get a distance function for the point below the I and the j. So we've got these three distances, and now we're going to get some differences between the distances. So the distance between the east distance and the center distance is going to be x. The difference between the south distance and the center distance is going to be y. Then we're going to turn that into a vector. Now let me comment this out and comment this in. So if we create a vector with x and y, we get this. But how does creating a vector from the differences in distance create these lines going towards the center point? It didn't make sense to me. So we have to look at an example. So to understand why this works, let's look at 3 different points. We'll start with a point over here. And so we're going to get a distance from here to here. And then we're going to look at a point to the right of that and get a distance from here to here. And we're going to look at what is the difference between these two distances. So the difference between these two distances, let's say, is 1. And now we're going to look at the point down here and look at this distance from here to here. And let's say the difference between these two distances is 0. They're the same distance. So our x is going to be 1, our y is going to be 0, and we're going to create a vector from that. So we create a vector, and it's going to be pointing this way because x is add 1, y is not add 1 or 0, so it's not going up or down, so it's just pointing to the right. Now let's look at a point down here. We calculate that distance. Then we look at a point to the right. We calculate that distance. And the distances here are the same. So that's going to be our x is going to be 0. Now we look at a point down here. We calculate that distance and get the difference between those distances. Let's say that is 1. So now we're creating a vector from 0, 1. So if we're starting here and the x is 0, we're not going to the right or to the left. The y is 1, so let's say we're going up. So now this vector is pointing up towards the center. One more example, we'll do a point over here. We calculate the distance here. We look to the right and we calculate this distance. Figure out what is the difference between these two distances. Now, the difference between these two is not going to be 1 or 0. It might be 0.5. And then we're going to do a point down here and calculate that distance. And the differences between this distance and this distance is also not 1 or 0. Let's say that's also 0.5. And so now we're going to create a vector. Let's say it starts here. And we're going to go over 0.5 and up 0.5. So this vector is going to be pointing up this way. So notice all of these vectors are pointing towards the center point. And if we wanted to get a vector that instead of pointing towards the 0 point was pointing in a clockwise direction, we would just rotate this vector 90 degrees. So then our center point, this vector is pointing this way, this vector over here is pointing this way, this vector over here is pointing this way. And actually, not quite yet, because we're going to be getting this. So we create a vector for x and y, and it gets returned to the function up here, and this is what it would look like if we would just return that vector. But this has different magnitudes of each vector. A vector has a direction and a magnitude, but we are not interested in the magnitudes. We are only interested in the direction. So that's why we call this normalize function. This turns the magnitude to 1, and now we just have direction with a magnitude of 1 for all of these. But right now, all of these vectors are pointing towards the center. We want these vectors to rotate around the center, so we need to turn them all 90 degrees. So to do that, we need to switch the x and the y and make the x negative. So we'll comment this in and comment this out, and now we have vectors that are rotating around the center. Another option to rotate the vector 90 degrees would be to use the rotate function, so it would be vec.rotate half pi. So the make gradient function is doing this for every point in this grid. Let's go back to here. And actually, when it comes back to here, let me comment this out, because we actually only get this returned. When we say the vector is normalized to 1, that's 1 pixel. So these are lines, but they're lines that are only 1 pixel long. In order to see what they are, we're increasing that by multiplying. And with vectors, you can't just say g1 times 5 because it's a vector. So you need to use vector math, and that's what we're doing here. We do g1 dot mult for multiply, and we're multiplying that vector times 5.5 to get this. If I multiplied it by 15, then I'd get really long lines. So after it comes back with a 5.5 vector for g1, then we're creating a line from our current ij position to I and j plus the vector of x and y. And so that is what we're getting here. Each of these lines is being created by this.
If you add this result from this gradient function that we created to whatever your current point is, you'll start moving around in a circle. That is how you could use this technique to figure out if you're tracing, a path through this field. You can then draw lines each time you take a step, or draw whatever you want. The way I approach making things these days is I spend time thinking about, okay, well, what are these underlying functions and what are interesting fields to play with? And then I make code that sort of draws based on whatever's in there. One of the things that's kind of cool about this is that if you have like a vector pointing this way and you add it to another one, right, you'll get one that points this way. So if you add fields together, you get this crazy, potentially really interesting set of things coming out.
Dan Schiffman has quite a few videos using vectors and vector math. So I think I'm going to have to watch a few of those to
yeah, he's great.
Get more familiar with this whole concept and how to use it.
Once I started sort of getting comfortable with using these, I use them for almost everything now.
Yeah.
But that's the kind of work that I create. So I'm not really making a lot of very geometric kind of work. I like to go more organic, and that's clearly what
everything's got to have curves. Yeah. I'm in favor of curves as well. But this is showing rotation all across the canvas. We want to see a defined circle. So to see a defined circle, we're going to uncomment this in the distance function. And this is saying if the distance that is calculated is greater than the width times 0.4, we're going to return 0. So if the distance is out here, and this is width times 0.4 from here to here, then it's going to return 0. If it's within this width times 0.4, then we're going to return a distance amount.
Now you've created a function that's based on the distance. And that's kind of what SDFs do for you. You can get like libraries that will allow you to easily combine them. And you can do squares and line segments and arcs and circles and all this stuff. And so when you then add those together, then you can get really interesting things happening in terms of control fields.
Now we're going to move on to another example. This is bound circle plus flowing for YouTube. And what we want now is to make this, instead of all the segments being short, we want to have several segments attached to each other to make a longer line. So we've replaced the I and the J with R and S, and now we say I equals R, J equals S. You'll see why in a minute. And then we have an additional for loop. This is for the line segments. Right now I only have one line segment. I'm doing the same thing here. It makes a gradient. It goes here. This is all the same as before. Actually, I want to change this from step to length. I've added length at the top. Len equals 5. There we go. Got that fixed. So all of this is the same as before. Then it comes back to here. We're having a normalized vector returned. We multiply it by the length, and now we make a line from the I and the j to the I and the j plus the vector of x and y. So all of this is the same as before, but this is a little different. We're going to get a new I and j. That is, we're going to get to the end of the first line segment, and that's going to become the beginning of the next line segment. And then we're going to go a little ways, and then the end of the next line segment is going to become the beginning of another line segment. And we're going to keep doing that for however many line segments we want. So we're going to create a line of small line segments. If I want 5 line segments, then I just have to change this from 1 to 5. And there we go. We have a flow field. It's got 5 line segments of length 5. I could change the length here to 3. And now it pretty much looks the same, but I've got 5 line segments, each of length 3. Now we'll move on to another example. Again, we have length. Let's make this length 3 so it's like the one before. We've got the line segments. Let's say there's 5 line segments. I've got it randomized so it's putting the circle at a random XY position, and it's got a random radius. But the way I'm doing this is I'm first putting circles into an array. At the top, I've got circles equals an empty array, and then I'm pushing the x, y, and radius into an array, circles.push, create vector x, y, and radius. And normally you would put x, y, and z perhaps into a vector, but I'm sort of cheating here using the third position of the vector as a placeholder for my radius. So at the moment, I'm only putting one circle into the array. So if I change this to 5, you'll see that now it's creating 5 circles. So let's see what's different now with the code. This part is the same. This part is the same as before. And this for loop is the same as before. But you see right here, I've got g1 equals create vector 0, 0. So this is starting with an empty vector, basically, naming that g1, because I'm going to be adding stuff to g1. So after my for loop for the line segments, I have another for loop for the circle array. So I'm going to go through the circle array, and for each circle, I'm going to make gradient for the I and the j, and now I'm sending the n as well. N is the number of circles in the array. So first it's going to send 0, and then it's going to send 1. So we go to the make gradient. The make gradient is receiving the I, j, and n, and we're sending to the distance function the I, j, and n. And let's look at the distance function. So we're receiving that I, j, and n, and we're calculating the I and the j to the center of each circle. So first it's going to be calculating the distance between the I and the j and the first circle, x and y. And if the distance calculated is greater than the radius of that circle, then we're going to return 0. Otherwise, we're going to return the distance we calculated. So we do that for the center point, for the east point, for the south point. All of this is the same as before. and we finish up with a vector, which is normalized, and we return that. So we go back up to here, and now we're going to add the vector that gets returned to G1. So that make gradient returns a vector, and that's G0, and then we're going to add G1 to G0. Remember that G1 started off as an empty vector, so once we return with that first circle's vector, then we're adding that to the G1, and that becomes a new G1. Now, with vectors, you can't just say G1 plus G0 because it's a vector. So you have to use this vector math, p5.vector.add. There's a video that Dan Schiffman did on vector math. I will leave a link to that video in the video description. So when we're done here, the G1 has the vector for the I and j position to the first circle. Then we move on to the second circle. We do the same thing for the second circle. We get the vector for the I and the j to the second circle, and then we use this vector math to add again. So now we're adding the first circle's vector to the second circle's vector, and that becomes the new G1. We do that again and again for each circle in the array. So in the end, we have added up all of those vectors for the I and j position for all of the circles. So at the end of that, we might wind up with a vector that has a large magnitude because we're adding a whole bunch of vectors together. So we just want the direction that all of those net to. So we're going to normalize that, put the magnitude to 1 so that all we have left is the direction. And then we multiply that by the length that we want for our line segment. And that becomes the line I and j to I and j plus the vector x and y. So we're just about done with this project. Notice that these two circles are intersecting and the vectors are offsetting each other. This one is going this way, this one is going this way, and we're getting a different sort of flow happening for the vectors where these circles interact. So I have what I needed for my flow field project. Let's now combine this with the flow field work that we did in my last video. So here's the flow field work from my last video on flow fields. So the flow here has multiple line segments, and this has multiple line segments as well. So first I've added the empty circles array to the top. Then I've got this for loop pushing 5 circles into the array. This is exactly like it was in the code we were just looking at. Then looking down here, I've got the for loops for the width and the height. I've got the for loop for the segments. What I'm missing now is the for loop and all of that vector stuff for the circles. So I've copied all of that over here, and I did have to change some of the variables in order to get this to work because I was using some of the same variables in both sets of code. Now nothing different is showing up yet because I've got two different ways of creating line segment. I've got one way of creating a line segment coming from noise, and I've got another way of creating a line segment coming from these vectors for the circles. So what I've done is I've got a new x1 and a new y1, and then a new x2 and a new y2. So this one is for the noise, and this one is for the vectors with the circles. So then I have to combine those two. I'm going to get a new x and y using one method. I get a new x and y using another method. I combine those together and take an average. So I'm going to say new x and new y, And if I said 50% for each, then I'm going to get new X and new Y here. And this is what it looks like when I do 50% for each of these. Now, let me see. I think I need to make the line segment a little bit longer. Let's make the length 5. There we go. That's better. So the circles aren't showing up very well, unfortunately. I'm going to change this so that the new X using the vector method is 60% and the new X using the noise method is 40%. So let's do that. And that's kind of interesting as I change this. And now we'll change this to 0.6 and this to 0.4. And there we go. Now we've got our flow field, plus we've got some circular rotation where the circles are. And it all flows together. Now think about this. I'm combining these two methods that are very different from each other, but they're in common in that they both create line segments. So I'm able to combine them because I just combine the line segments. This means that if I come up with some other method of creating a line segment, I could also use that and just combine the line segments. So that's pretty cool. Let's make the stroke weight a little bit bigger. There we go. That's a little easier to see. I think we're done with this project.
So this project is using all of the stuff we just talked about under. And so if you go scroll down a little bit, you can see like some of these shapes, like this one here in the lower right, the green with the two circles. What, you know how I was saying tracing these things? That's exactly what this code is doing. So it's like sort of going through that field that we created, all those different vectors, and sort of tracing around. And you can see on the background, there's this noise that's, I can't remember what that one is, but it's some form of noise. And then these are just circles that I've overlaid across one another. And then I'm sort of swapping back and forth between, you know, the direction that I go. Is it going the perpendicular or is it going the straight way? And so that technique is really what this whole project is. And so you can do all kinds of crazy stuff when it comes to sort of structuring, adding fields together and making interesting results.
Really honored that you spent all this time with me. It's really nice of you.
Yeah.
I really appreciate it, Jeff. Thank you so much.
Yeah, my
Appreciate
pleasure.
your time. So I'm saving this. All the code I've shown you is available in the video description. There's also a link to Jeff Palmer's website and his fxhash project. Also, there's a link to my 2 fxhash projects that both use this circular flow, the Inflow project and the Espresso Dreams project. Go check out the iterations for those. They're pretty cool. If you've liked this video, you can give this a like, consider subscribing to the channel, ring the bell for notifications. Comments are always welcome. Love to read your comments. Thank you for watching. I'll see you in the next one. Bye now. Steve's Makerspace.